In this problem, I want to take these two forces in couple moment and replace it uh, with a single resultant force at a specified location. Okay, so what I need to do is this two-step problem here. First, I'm going to take everything and move it over to this point. Okay, so I'm going to have a single force and a single moment at that point. Basically, reduce these two forces and a couple down to a single force and a single couple at the end point. Okay, so my resultant force, I just sum the forces together, right? So it's going to be 6 minus 10 equals minus 4. So I'm going to have a resultant force of -4 right there. Okay, my resultant moment, remember, is going to be all of my couples plus my R cross Fs. This time I do have a couple moment. It's a positive 52. And then I'm going to have 3 times 6. That'll be a positive moment. And then I'll have -9 times 10, which will give me a resultant moment of -20. So again, what that means is I've got -20 like so. So these two are are equivalent, right? I can either have the two forces and the couple moment at those different locations, or I can reduce it to a single force, a single couple at that endpoint. They have the same external effect on this guy right here. Now, I can take it a step further, and I can only do this in two cases. The first one is right here, which is when I've got a coplanar system, basically a two-dimensional system. The other we'll do later, but it's where all the forces are in the same direction. Okay, and we'll talk about that one later. But this is one case. When I have a 2D problem, I can take all the way down to a single force. And what I do for this is essentially I'm going to say, okay, I know my resultant force is -4. The question becomes, where can I place that 4 kilonewtons so that it creates that -20? Basically, the question becomes, what location D do I put that force to create that -20? So what I do is I have my resultant moment that I've calculated. I want my D crossed with my resultant force. So essentially what I have here is I'm trying to solve for D here, right? So I have -20 in the K direction. Okay, D is unknown, but I know it's in the X direction, so I'll say D in the I direction. And then I have FR, which is crossed with -4 in the J direction. Okay, so then what I get here is -20K equals well, I'll do it this way, -4 times D in the K direction. And from that, I can find that D needs to equal 5 meters. So what I can do is this is also equivalent. So I can take those two forces and couple moment and reduce it down to a single force. Okay, that's located 5 meters from the end of the beam, and it has the same external loading effects as what I have at the original problem. So it's just a way to reduce it down to a single force. Okay, two things. Remember, this only works for coplanar problems or in problems where forces are all in the same direction. Okay. Um, the other thing to remember is it does not actually have to be on the body, right? This force, you know, is a, yeah, a mathematical theoretical force. Therefore, it doesn't necessarily have to be on the body. It could be to the left or it could be all the way off the end of the beam. It's basically saying this is an equivalent location where the force would be if I was going to reduce it down to a single force at a specific location. That location does not necessarily have to be on the body.